write it in the chat or open the mic, interrupt the class if you want, and I will help you, right? I will help you, don't worry. Okay, so let's begin with exercise 8E. Okay, thank you, Juanita. I appreciate that. Thank you for letting me know. All right, let's begin with exercise 8E. And we're going to do a couple of the first, and then a couple of the second, and then a couple of the third, right? If you have any more doubts, we will do some specific exercises after the ones I propose. So let's begin with the first one, exercise 8E. Point 1, question A. So in this part, the book is asking us to say if each statement is either right, true, or wrong, false. So we need to say true or false. All right, so let's focus on the first one. F contained in G. F contained in G. All right, now I like to read it like this, contain. But the idea of this little sign is that every single element in F is also an element in G. And as you can see in the book, this part, as you can see in the book, let's see if I can show it to you. Yes. All right. As you can see, not every element in F is also an element in G. Look at this. This little dot over here is a dot that is inside F. But that little dot is not inside G. Also, this one and these two over here, these 4 dots, these 4 elements in F are not inside of G. Meaning, F is not contained in G. Not every element in F is also in G. This one is false. All right, let's go to D. I'm going to do D now. I'm going to do D. Why? Because again, I said I was going to do a couple of some exercises and then a couple of some others. Again, if you want me to do some specific ones, absolutely. Just let me know and I will. All right, so let's go to D. Now, the question is the amount of elements. So here, the amount of elements in F union H. In F union H. This, according to the book, is 6. Now, let's see if that is right or not. Let's see if that is correct. Let's locate in our book, let's locate the union between F and H. All right. The union between F and H will be this one. This is F and this is H. So we are looking, since we're looking for the union, we want to count every single element inside F and H, right? Inside F and then the ones inside H. So inside F, we have 1, 2, 3, 4, 5, and 6. Let me count them again. 1, 2, 3, 4, 5, and 6. Now, some of you might be saying, teacher, sure, but you're counting the ones in G. Shouldn't you just count the ones in F? Okay, but look, G in this case, G, the little ball of G, is also inside of F. So every single element of G for this exercise is also an element on F, right? So we have 1, 2, 3, 4, 5, and 6 elements of F. 6. Plus another 2 of H. Look, H have 3 elements. But this one, this little one, is in the intersection, right? And this one we already counted. When we were counting F, we count this little dot already. So we have 1, 2, 3, 4, 5, 6, and then 2 more. So 8. The amount of elements between the amount of elements in the union of F and H is 8, not 6, meaning this is also false. All right. Now, guys, in the chat, please let me know if you are following me so far. Just go ahead and write yes or write no, teacher. I have no idea what you're saying. Please. Everybody, please. I need everybody to answer. Thank you. I see some of you are answering, but not everybody. I want to know if any of you have doubts. Beautiful, beautiful, beautiful. Beautiful. I have one person who is having difficulties. All right, one person who's having difficulties. Cesar, if you want to just open the mic and ask me the specific questions, Or if you prefer, we can do a tutoring later. All right. Which one? Do you want to ask me right now? Cesar?
Sorry, teacher. Yes, it can be later.
Okay. All right. If you wish. All right. We can do it right now. It is okay, buddy. Or we can do a tutoring later. So I'm gonna send you the email with the tutoring invitation. All right. Okay.
Thank you.
Let's continue. So I think that is enough for now. I think we have been looking at this sign, which is kind of rare. We don't use this sign a lot, and this little n, right? So this means the every single element in one set is also in the other one, and this little n means that we are just going to count the amount of elements in the set. So I think that's it for now, unless any one of you want me to do a specific one. If that is the case, just let me know which one. But I'm going to jump into 2.
Gus,
Yes,
You can make
I
D.
have a question.
sure, tell me.
The form in which in the A, de la cosita, no importa para dónde esté mirando,
Which cosita?
the middle one.
This sign?
F,
This
yes.
the subset sign? This is the subset sign. So, all right, let me see if I get it.
Uh,
You're saying is, teacher, does this means the same than this?
yes.
No, it kind of does, but no, they don't really mean the same. All right, let's write it like this. If you write it like this, you're saying that A is a subset of B. A is contained in B. If you want to draw it, you will have B over here and A over here, right? So the set A is inside, is contained the set B. A is a subset of B. Every single element in A is also an element in B. But if you write it the other way around, A and B, now you're saying, and you will read it like this, A is a superset of B, meaning backwards. Try to read it backwards. B now is a subset of A. B now is contained in A. Every element of B is contained. Every element of A of B, sorry, is also an element of A. So if you want to draw an example, a Venn diagram for the second one, you will have something like this. A big one, which is A, and then inside a little one, which is B. And every single element in B is also an element of A. All right? So they kind of mean the same. They kind of mean the same, but not really. The order matters. Which way the little sign is facing matters, because that is what tells you which one is the bigger set and which one is the lower or smaller set.
Okay.
All right? All right.
Okay.
No
Thank
problem.
you.
And there was another person asking something.
Teacher, I have a
Yes?
question. Yeah, I have a question, teacher. Is that, well, I don't know, but in the videos and in the book, they said that the subset is with a line below the the subset thing. Yes.
Okay.
So
The sign.
why we don't? Yes. Why we don't put it the line below? It's like, because they said that the subset is like that and the superset is, wait a moment. The
Sure.
subset is like that and the superset is without the line.
Absolutely. Look, I'm going to do an example for numbers, not for sets, all right? But for numbers. Take a look at this, please. 5 is bigger than 5, all right? 5 is bigger. X is bigger than 5, all right? So we are familiar with this sign. We are familiar with this sign. We know that X is bigger than 5. So X can be a lot of possible numbers. We know X can be 6, 7, 8, 5.1. Right? We have a lot of possible numbers, right? But let me ask you something. Can X be exactly 5?
No.
No, right?
No.
What are we missing for X to be exactly 5?
The line below.
The line below, right? So this one, will be the sign explaining or showing that x can also be 5, right? Let me write it better. Like that, right? Here
Yep.
you have x is bigger than 5, and here you have x is bigger or equal than 5, correct?
Mm-hmm. Yes.
Beautiful. The exactly same things happen with sets. So we have one set that can be a subset of another, or we have a set that can be a proper set of another. The little line under the sign it signifies that the two sets can be the same. They can be the same. What I'm saying is, if I draw a diagram for each set, and I'm saying in set A you have the numbers 1, 2, and 3, and in set B you have the numbers 1, 2, and 3. Did you see what I did?
Yep.
Would you say these two sets are different, yes or no?
No.
They are not
Because they're
different, right?
doesn't matter.
Beautiful. They are the same. It doesn't matter, but because they have the same elements, they are the same set. So you have indeed A equal to B. The two sets are the same. But since every element in A is also an element in B, 1 is an element in B, 2 is an element in B, and 3 is an element in B. Since this is happening, you can also write it like this, because A is also a set of B, but with the possibility of the two sets being the same. When you write it like this, you are taking away that possibility. Just like in these examples with the numbers, you are taking away the possibility for the x to be exactly 5. So if I ask you to draw a Venn diagram for these two examples, for this one over here, the only possibility is that the two sets are not the same, are not equal. So the only possibility is that one is inside the other one, like this. A and B. For this drawing, the drawing for this example could be something like this. The two sets being exactly the same, something like this. This is A, and it is also B. That could be an example as well. The exactly same circle. Because you're saying in here, the possibility is that A is also equal than B. When you have this little sign over here, they are not the same. All right. Now, if you want to go even further with this topic, you can go, I don't know which part of the book is. I don't know which exactly page of the book is, but you can look for proper sets and improper sets, which is the one topic that we discussed the previous class. All right. One of these is the proper set, and one of these is the improper set. Now, I'm not going to tell you which because I want you to go ahead and read it, please.
Yes, but I mean is the form of the symbol. I can explain. The subset symbol is the C with a line below,
Okay.
and the above one without the line
It's, it's
is
also it's also the subset symbol. It is also the subset symbol, but
and the
without the
proper subset.
possibility of the two sets being the same.
Okay.
Look, vamos a pasar un momentico en español, a ver si de pronto ese es el problema.
Qué
¿Dirías tú que este es el símbolo de mayor o igual?
Sí, sí, sí.
No, este es el
Ya
símbolo solo de
entendí.
mayor que, no mayor o igual.
Ajá, mayor es mayor que.
¿Cierto? Muy bien. Este es el símbolo de mayor que con un poquitico extra. Pero este es el símbolo de mayor que. Este es el símbolo de mayor que o igual. ¿Cierto?
Ujú,
Aquí
sí.
pasa lo mismo. Este es el símbolo de subset. Este también es el símbolo de subset. A también es un subconjunto de B. También. Lo que pasa es que es un subconjunto sin contar la posibilidad de que sea el mismo diagrama, el
Ah,
mismo
ok, ya.
conjunto.
Listo, ya. Ya la entendí,
¿Sí?
ya, qué pena.
¿Mejor?
Sí, sí, ya. Sí, ya,
Bueno,
gracias.
listo. No pasa nada, mi niña, con muchísimo gusto. Any other question, guys? No? All right. I don't know who, but I know somebody said, teacher, can you do? And I couldn't hear which exercise. Somebody? No? Okay, then let's jump into question 2. All right. Just like in this exercise, we're going to do some of them. I'm going to begin with the first one. I'm going to begin with A. We're going to do A, right? Okay, now in A, in the question 2, they want us to list the elements of the universal set. For question A, we want to list the elements of the universal set. Okay, so if we want to list the elements, we want to make sure we use proper notation. So this is the name of the set, U. In question B, for example, the set will be R. So you write down an R in here. Then you say equal to and open these parentheses over here. That bracket, right? That curly bracket. Now this one, remember the last class we talked about this. This one kind of means is the set of. So you will read this entire sentence as U is the set of. And inside the curly bracket, you will write down all the elements of U. Okay, now in the book, I can see the elements of U are every single element that you can find inside the rectangle, because look at that. That is the U. The U is for the entire rectangle. And we have these elements. Now, make sure you don't write the R and you don't write the T. Those are not elements. Those are sets. All right? How do you know? Because of the capital letter. If you find a capital letter, then that is not a set. That is not an element. It is a set. And you don't count it because you are being asked to write down the elements. Here, write down the elements, right? Not write down the sets, not write down the elements. All right, so go ahead and read the elements, please. You have all of these little letters, right? So B, D, K, or X, I think it's K, F, E, C, G, and H. Go ahead and write it. The order doesn't really matter. You can write it alphabetically or no, it doesn't really matter. Just make sure you write all of them. So let's begin with B, D, K, B, D, K, F, E, C, F, E, C, and G, H. G, H. Beautiful. Close the curly bracket, and there you go. We finish listing the elements on the universal set of the point 2. That is it. That easy. Now, that was an easy one. Can we do even better? Let's try to do question C. Question C is a little bit better, a little bit more interesting. All right, they want us to list the elements in the set are with a little thingy on top, with this little thingy over there. Do you know what this little thingy implies? In the chat, please. Nobody? Thank you. Some people are answering. All right, beautiful. Complement. Thank you, Isa Rodriguez. Thank you. All the elements except the ones in R. Beautiful. Beautiful. That is the idea behind this little thingy. You read it as R complement. Now, in calculus, we have seen this little thingy before, right? In calculus, this is the prime. Remember, it signifies the derivative of R, right? But that is for calculus. That is for functions and continuous functions and mathematics or another type of mathematics. But in here, when you're talking about sets and a set and Venn diagrams, what we are using this prime for is to show the elements that are not in R. So the complement, right? Remember, the complement means the ones that are not in R. All right? Okay. So let's try to list these elements. All right. Again, equal and then open a curly bracket. So now we want to think on all the elements that are not in R. That is the idea of the prime here. The ones that are not in R, the complement. Okay, so we can see that the ones in R are the elements in this circle. So we want to look for everything else that is not in this circle. So should I put in my list, should I put the letter B? Well, no, right? Because B is clearly inside this circle, inside the set R. So I shouldn't include B. Same with F. I shouldn't include it. Should I include D? Yes or no in the chat, please. Should I include D or no? Okay, I have one answer. Another one. Okay, people are now beginning to answer. Beautiful. You are right, guys. Thank you. You are correct. I should not include D. Even though it looks like it is outside, it is being separated from R because of this line. If you look closely at the R circle, look at that. The R circle contains the letter D and E. These two are inside R. These two are part of R. So you are not going to include any of these four. Meaning, the list of the elements on the complement of R complement, are going to be the rest. K, C, H, and G. Let's write it down. K, C, F, and G. F and G. Close the curly bracket, and we are done. That is it. I think with those two, that would be enough. So unless you guys have any other questions, I'm going to continue with the third one. Do you guys have any other question or not? All right, let's go to question 3. And I know I'm going a little bit fast. I know that, but it's only because we only have 25 minutes for these guys. Because I need you to practice yourself. I know when you guys get to practice, you will have difficulties. And I'm hoping that you ask me those questions, all right? We're going to take as much time as you want in that part, all right?
Teacher,
Yes?
why did you put F?
F, look. Where is F? Ah, no, it's G. I mean to put,
I was
no.
like, what?
H. H is the one I meant to put. Here, H. Thank you, Maria Paz.
Okay, teacher.
Thank you, Maria Paz. All right, let's continue with question 3. In question 3, the question wants us to, again, list the elements of a bunch of sets, right? But the diagram is different. The diagram is different. So let's begin with some different ones. I am not going to do A or B. I feel like those are the easiest ones, the easier ones. I want to do C. C looks interesting. C looks interesting. All right. I want to list the elements inside the union of A and the complement of B. Man, that looks hard. The union of A and the complement of B. Again, an equal sign and then curly brackets. Man, that looks hard. It isn't. It isn't hard at all. All right. Let's look at the drawing. Let's look at the drawing. Since we are doing the operation of the two sets, the operation between the two sets are union. Since we're doing the union of the two sets, we know in our minds all we have to do is count every single element that we find. That's it. We're going to list every single element that we find. All right. And inside A, we have all of these 5 elements. We have B, Q, X, W, and D. But B, look at that. B is in capital letter. B is in capital letter. Meaning B is the set, right? B is not an element. So we only have 4 elements inside A. Q, X, T, and W. B does not count because B is capital letter, signifying that B is a set, right? So this list have to include, it has to include the elements Q, X, T, and W. Let me write it down. Q, T, X, and W, right? But it is going to include more because over here, I just listed the elements on A. I haven't listed the elements on the complement of B. I'm going to do that right now. Let's look at the diagram and think of the elements outside B. That is the idea behind B complement, the ones that are not in B. So the ones outside B. And outside of B, you're going to find these. qxw, these three are outside of B, right? But also P and what is the letter? An F, right? P and F, right? But then the question comes, teacher, what do we do with T? What do we do with this little letter? With T, right? Do we count it or not? And yes, we do. Because remember, the operation between the two sets is union. So you want to include everything in the first set and also everything in the second set. So even though T is outside B, I mean the complement of B, right? Is outside of B, you are still going to include it in this entire set, in this listing, simply because it is in A. Got it? All right, so let's write down every single element as well, outside of B, right? So in the B complement. So we have Q, X, and W, but we already have those, Q, X, and W. So we are not going to write them again. Remember, the list of elements cannot have repeating elements, right? If you have Q, you cannot have Q again. That would be a mistake. So we already have Q, X, and W in this entire set. Let's write down the rest. We have P and F. We have P, and we also have F. Close down the curly bracket, and we are done. We finished with the union of these two sets, A and the complement of B. That one was interesting. Now, after you've done things like this, you can say something like, look, you can say something like this. The union between A and the complement of B is equal to a set. Is equal to one set. I am not going to open or close any brackets. I don't want to list the elements. No, I want to say that these two are equal to one set. Please, in the chat, write down the element, the set, sorry, that these two sets are equal to. Let's see if somebody gets it. Of course, Lau would get it. Of course, Lau would get it. Of course, Lau would get it first. But everybody else got it as well. All right. Congratulations. Yes. Since every single element between the brackets are every single element inside U, look at that. U has all of these elements. If I ask you to list the elements of U, you would say the elements are Q, X, W, T, P, F. These ones. Every single element of U. So these two sets are the same. The universal and the union between A and B complement are the same. Now, these are the type of questions that you may have in your IB program or your IB examinations. Something like this. According to the Venn diagram, say if this is right or true or false. That would be the type of questions you would have. Or like this. A union B complement is equal to, and write down a set that is equal to these two, and then you will have to say the union, right? Beautiful. Now, when I was studying, this happened to me. When I was studying, this happened to me. Maybe it has happened to you, so I'm going to tell it right away. How do you recognize the union from the universal set? How? How? Honestly, they are written the same way. They are written the same way. Both of them are used. Now, I like to do my union a little bit bigger, but the universal set, since it is a capital letter, is also bigger. So how do you recognize them? In my experience, the more exercises you do this, so experience, you tend to recognize that the letter between two sets is an operation. So in here we have set A and set B complement. We have two sets, meaning the letter between those two have to be an operation. And what is an operation that is signified with a U? that is shown with a U. Union, meaning this one is union, right? Again, the letter between two operations is the letter between two sets is an operation. Here, you don't have any two sets on the sides of this one. So this one cannot be an operation, meaning this is the universal set. That is how I know the difference, all right? In case some of you is having these difficulties. All right, let's do another one. Let's do one with intersection. Let's do one with intersection. That would be fun. Intersection is fun. A lot of people have difficulties with intersection. So I want to do intersection now. All right, let's do question D. In question D, we have the intersection between set A and B complement. The intersection between set A and B complement. All right, so as always, an equal sign and then open the curly bracket. And let's write down the elements between these, inside this set. The question is, how do you recognize them now? What are the elements inside this set? All right, let's think of the operation first. The operation is intersection, meaning you don't want to list the elements on A and then list the elements on B complement. No. You want to list the elements that are on both. The elements that are on both, the ones that are common on A and B complement. The ones that are common, the ones that are in A and are also in B complement. So let's look to our diagram. Let's look at our diagram. In set A, these are the elements of set A, right? We have Q, that looks like a Q, yeah. Q, X, W, and T. These four are the elements inside A. All right. Now, let's think on the elements in the B complement, in the complement of B. All right, the complement of B will be the ones outside B. So everything else excluding D. Q, X, W, P, and F. Those are the elements outside B, so in B complement. Now the question is, since we are using intersection, what are the elements that are on both? The common elements. Please write them in the chat if you can see the elements in common. Let's see if you get it. Okay, Gaby Ramirez. Gaby Ramirez did it. All right, Gaby Ramirez did it. Beautiful. And then some of you write another solution. All right. Some of you are saying that the ones in common are D. Okay, the ones in A and B are D, right? Okay, inside A and B, the ones in common in A and B is just one element. D, this one over here, right? But look at this, we are not doing A and B, we are doing A and B complement. So the ones outside B, the element T, this one, cannot be in that set because it is inside B. And we want the ones outside B, the complement. In other words, inside A, we have these four elements, Q, X, T, W. Which of those four are also outside B complement? I'm sorry, outside B. Well, not T, T is inside. So the only ones that are outside are going to be Q, X, and W. So let me write them right here. Q, X, and W. Curly bracket closing down, and we are good to go. That'll be it. Again, even though the diagram might be showing you one thing and you may be familiar with that thing, you guys need to remember what is the set that the question is asking. In this case, we are not talking about B. No, we are talking about B complement. Remember the little thingy, the prime? B complement. So the ones outside of B. All right? Beautiful. Okay, I think we're gonna stop doing this exercise right now. If you have any doubts, you can ask me. But if that is not the case, we're gonna jump into the next part of the class. Did you have any more doubts, guys? Yes or no? In the chat, please. Okay, one person is answering. Nobody else? Thank you, Maripaz. Juanita, thank you. Gaby, Lau Gaitan, Juanita Diaz. Thank you, guys. All right, thank you, guys. Appreciate it. Thank you. So, I'm going to stop the video now, and we'll continue with the rest of the class in a second.